Hi, this video is going to cover what binomial distributions are. This is section 11.9 in Algebra 2. First of all, here is what a binomial experiment is going to have. So binomial experiment. It's going to have a couple different things to be a binomial experiment. It has a fixed number of trials. It is each trial has two outcomes. Good example would be flipping a coin, heads or toys, tails, heads or toys. Those are two outcomes. Could be talking about weather, whether it rains or it doesn't rain. You have two outcomes. It either does or doesn't. The trials have to be independent from each other. The trials are independent. One does not affect the other. They're not dependent on each other. And the probability of each outcome is consistent throughout the trials. So the probability of each outcome is consistent. It means it stays the same throughout the trials. Basically, while you do each trial, your probability stays the same. It's consistent. You can't change from one to the next. Like if I'm flipping a coin, it can't change the probability. So maybe it's weighted a little bit and heads has more probability than tails. I can't switch and make it a normal coin in the middle of the experiment kind of idea. So binomial distributions are a little bit more challenging because they use Pascal's triangle again, and they bring in that binomial distribution that we've looked at before. And let's look at first what the binomial probability looks like the basic idea of it. Okay, it's going to look like the probability of whatever we're talking about is equal to n choose x. So we're going to use the choose, the combination, right? N combination x. And then we're going to have the probability to the x power. So it's whatever the probability is to the x power times something we call the q, which is the opposite probability, and that's n minus x. So that looks a little confusing. So let's look at this idea, use it, and tell you what each one is. N is going to be the number of trials. Okay, and then x is the number of successes. And p is the probability of the success. It'll probably make more sense when we see an example, but and q is basically 1 minus the probability, or the p, right? It's the probability of failure. So if the probability p of it raining and being successful raining is let's say 0.4, then the probability of not raining is 0.6 because they have to add to that 1. So that's kind of the idea. So we can put numbers in if we have an example and use them in this formula. So my first example would be, what if I just flat out tell you n is 5, x is 4, p is 0.4. And I say, what's the probability given those numbers? Well, we would say the probability of x is equal to it goes in, choose X, so of 5, choose 4. And then zero point 0.4 is our probability to the power of X, which we said is 4. And then we would times that by the failure, which we don't got. We don't got. Just do 1 minus zero point 0.4, so that's 0.6. So these two probabilities will always add to 1. And then the probability is of this one is n minus x. So n minus x is 5 minus 4 on this one, or 1. Okay, and that is how you take an experiment and put it straight into this probability that they gave us. Okay, so let's see. So what we're going to do now is I'm going to use the calculator for the choose, the combination, and on my calculator you hit 5 first, and then I'm going to hit this math key over here, math, and I'm going to go over to probability, and I went too far, probability, and go down to the choose, and then I have to tell mine R, which was 4, and that's the answer is 5. So I now know this is 5, and then I can calculate what 0.4 to the 4th power is. It's 0.0256, and then 0.6 to the 1 power is 0.6, and then I times those all together, times this 1 times 5, and I get the probability of x to be 0.0768. So this is kind of how you use it. So we know n is the number of trials. That's how many times we did it. There were 4 times that you were successful in those trials, and the probability of success is 0.4. So what's the probability of x? It's pretty low, 0.0768. So sometimes you're given the information, you plug it in, and then you're done. So let's look at using the binomial, what the binomial theorem is again in terms of probabilities. So binomial theorem. And we've looked at this before. So let's say we have a, b to the n. Then it would be like, this is how it would be written out. You'd say n choose 0 of a, that's the first thing, to the n, plus n choose 1 of a to the n minus 1 b, plus, I'm going to run out of room on this paper, so hang on, let me scroll this paper down. So then the next one would be, can I fit it on the end there? I think I can, n minus 1. The next one would be n choose 2, and it would be a to the n minus 2b squared, plus, and then I have to go to my next line here, I would just keep that pattern up until I got to n choose n. Okay, I've ran out of the number of n's, n choose n, so I start at 0, 1, 2, and then I keep going until I have the same number there, and then you would have, interesting, a, and then b would be to the n minus 1, and the last one, n choose n, b to the n. So you're going to keep going in that pattern. I can have it crooked, right? So C is our choose, but then we're going to have n0, the first thing to the nth power, and then there's no second thing. Plus, now n choose 1 would be a to the n minus 1, so if n was 5, now I'd have 4, and b would be to the first, and then it switches and it's going to go down another one, but this one goes up. This one goes down another one, this one goes up. And then it keeps going in that pattern until you have just the b to the n power. All right, so that looks confusing, and it kind of is. Let's write one out that has actual things in it so it's a little bit easier to look at. What if, and this is just going to be my first example, what if I just have x plus y and I have it to the fifth? Okay, let's try our pattern here. So I'm going to do it on the next row to try to fit it all in one row, but it probably won't. All right, so this first thing that we're going to make this equal to is we're going to take the 5, that's our in, and we're going to go, okay, 5, choose 0. And then x is the first thing. It's going to be to the fifth power, and I don't have a y. Okay, the next one will go 5, choose 1. Now the x is going to go down 1 to the fourth, but the y is going to show up. Okay, now plus, now the next one's going to go 5, choose 2, and now x is going to go to the third, and y is squared, plus, now 5, choose 3, is going to be x down 1, squared, y up 1, 3, plus, now the next one will be 5, choose 2, oops, 3, 4, not 2, 4, I'm going up, 3, 4, 5, choose 4, now the x was squared, so now it's just x, and the y is now to the fourth. All right, almost done, plus 5, choose 5, no more x, and now y is to the fifth power. So x's started at 5 and went 5, 4, 3, 2, 1, none. Y's went none, 1, 2, 3, 4, 5. This is always your x, y, whatever the first is, whatever the second is. And then the chooses go 5, choose 0, 1, 2, 3, 4, 5. Now, phew, I have to actually simplify this sucker. 5 choose 0 is an actual number that you can come up with. And so we're going to come up with all those numbers on our calculator the first time, and then the next time, or then I'm going to show you using Pascal's triangle. So 5 choose 0. Well, what is 5 choose 0? It is 1. And you could use your calculator, but that one's pretty easy. 5 choose 0 is 1. 5 choose 0 is 1. Okay, so my first term is going to be 1, x to the fifth, or just x to the fifth, plus, okay, 5 choose 1 is 5. Okay, so 5 choose 1 is 5, and then you're going to have x to the fourth y, plus 5 choose 2 is 10, isn't it? 5 choose 2 is 10, yes, 10, and now this one was x to the third y squared, plus 5 choose 3, 5 choose 3 is 10 also, 10, x squared y to the third, plus 5 choose 4 is 5, x y to the fourth, plus 5 choose 5 is 1. So I'd have 1 y to the fifth, or just 1, or just y to the fifth. Whew! And that's your answer that you would type in. That is simplified as low as we can get it. Now check this out. Here is Pascal's triangle. And this one I just printed off. And what we were just doing is the fifth. So what were the choose numbers that we found? 1, 5, 10, 10, 5, 1. What did we get? 1, 5, 10, 10, 5, 1. Whoever came up with this pattern is super brilliant. So this probabilities go down just like in the chart here. So let's use that for our next one, our chart, instead of having to put into our calculator all of these choose blah 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 stuff. You like that? Blah blah blah. Man, I need a sharpened new pencil for this lecture. Okay, lots of writing. So let's try a little bit harder one. What if I have 2x minus 3y, and then I'm going to show you how to use this in a word problem with probability. Let's just do to the fourth because it's a lot to go out and with our different things. So let's look at this. Okay, so we know our pattern. Let's follow our pattern on this one. But now we have 2x on each thing that we have, but we're still going to have our 4 choose part here. Hold on, I was thinking for. Okay, so what if I had, so my first one would be 4 choose 0, and the 2x is our a, and that will go to the 4th power. Okay, plus now 4 choose 1 is now going to have our 2x to the 3rd power, but now it brings in negative 3y. Make sure when it's a minus that you think of it as a negative 3y, and that one will show up with, so it had not there, now it's there with 1 power, plus now we're going to do 4 choose 2, and that's going to have 2x to the 2nd, and then negative 3y to the 2nd, plus 4 choose 3, and now this one will just be 2x, and then this one will be negative 3y to the 3rd, plus the last one, 4 choose 4, and this will, 2x is now gone, and I just have negative 3y to the, not 3rd, but the 4th. Whew, ugly, but I don't want to calculate out all these chooses. So this 4 choose 0, if I go to the 4th row, I get 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So this is 1, this is 4, this is 6, this is 4, and this is 1. So it's kind of a cheat sheet thing. So now I just have to calculate this. What is 2x to the 4th power? It takes each one to the 4th. 2 to the 4th, I just spaced 16. I was thinking 8 and I knew I was wrong. So 16x to the 4th is my first term, plus now I have 4 in the front times whatever I come up with. So I'm gonna have to do it in 2 steps. 2 to the 3rd is 8. X to the 3rd is x to the 3rd, and then I have times a negative 3 and times a y there. So I have to still simplify that. That's okay. Well, I guess I could do it in steps. So here's my first one simplified. My second one simplified, I'm going to do all the numbers times each other. 4 times 8 times negative 3. 4 times 8 times negative 3 is negative 96. So I'm going to do it as minus 96 for the negative. And then x to the 3rd y. Okay, now the next one, 1, 2, 3, is going to be 6 times 2 squared is 4, x squared. Negative 3 squared is positive 9, y squared. And then again, I times my numbers, so 6 times 4 times 9. So 6 times 4 times 9 is 216. This is positive 216 x squared y squared. Okay, plus 1, 2, 3. So what? 1, 2, 3. Here's my next one. It's going to be 4 times 2x times negative 3 to the 3rd is negative 3 times 3 times 3 is 27. Y to the 3rd. Okay, so let's do this one. Negative 27. I have to cheat and do my, oh, that's not really cheating. Use my calculator for negative 27. Oops, this needs to be a negative. So negative 216 x y to the 3rd. And my last term here is 4 times 4 is, we're out of room here, is 1. This is 1 times negative 3, I don't remember to the 4th what that is, 81. So negative 3 to the 4th power is 81, so this is times 81 times y to the 4th. So that one's pretty easy, plus 81 y to the 4th. Whew! So 4th, 3rd, 2nd, 1, none. Y none, y squared, y to the third, y to the fourth, and our numbers are in there. Now that one I did on purpose. This is a hard one. This is as hard as it gets. Typically they only make you do, oops. Typically they only make you do one term. Like they might say, what is the sixth term of the, or not sixth, this doesn't have that many terms. What is the third term? 1, 2, 3. And you only have to come up with the third term. Okay, but I wanted to write the whole thing out so you know that's the first, second, third, fourth, fifth term. And so when it asks for just one term, you just come up with that one term in there. You could follow the pattern and just calculate out that one. You wouldn't have to do all the calculations out. These are long, and I do know that. But that is how you use the Pascal's triangle with the binomial theorem. Now let's do one problem that you apply the binomial probability. Okay, so this is binomial probability. Okay, so for this one, suppose you guess on 4 questions of a 5-choice multiple choice test. Okay, so suppose you guessed on the 4 questions of a 5-choice multiple choice test for 4 questions, n equals 4. So when I look at this, what I want to know is I have 4 questions, and then you have 5 choices on each question. So this what you first want to think about, what is the probability of the success of being correct when you have 5 choices. So what is the probability of being correct? Well, it is 1/5, right? 1 in 5. So what is 1/5 in terms of a decimal? It is 0.2. Okay, so the probability of being correct is 0.2. What's the probability of not being correct? We call that Q. Incorrect. Way more likely to be incorrect, you're 0.8, right? Because it is 4 out of 5 choices could be incorrect. So these are our probabilities, and these are our P and our Q. And the way that we do this is we do it as P plus Q to the 4th for 4 questions. And let's do this one out. I might do it a little quicker on the calculations without showing you a lot of them because I don't want to spend the time on it. So 4, I would go to my chart and I would know that they go, here's my 4th column, they go 1, 4, 6, 4, 1. So similar to what we just did. So we would do 1p to the 4th plus 4 was the next number, p to the 3rd, q, plus 6, that's from the thing again, p squared q to the 3rd, plus 1 q to the 4th. And this represents 4 correct, 3 correct, 2 correct, 1 correct. You could calculate these out and get your probabilities for each section individually. Okay, you'd put in the 0.2 to the 4th. So let's figure out the probability of getting all 4 correct. That is the probability of 1 times p to the 4th, which is p is 0.2. So this is 0.2 to the 4th power, which is 0.0016. So the probability of you getting all 4 correct on that quiz is 0.0016. That's not good, right? It's not a good probability. You want to be close to 1 if you're guessing. What would have been the probability of us getting half correct? 2 correct. That would have been 1, 2, all 3, 2. So that one would have been 6 times p, which is 0.2 squared times 0.8 to the third. Calculate that out. I'm just going to put it in my calculator. Times 0.2 to the second times 0.8 to the, oops, I forgot a parenthesis that I added in there. 0.8 to the third. I get, oh wait, I get a different answer. Did I get the 6? Times 0.2 squared. Oh. It would help if I didn't enter this in wrong. I was like, wait, I didn't get the answer. I still didn't. 0.8 to the third. Did I do that wrong? 6 times 0.2 squared. 3, 2. This one goes squared. This should be squared. Yeah, I did my pattern wrong. I didn't catch it. Shoot. Let's go back up and do my pattern. I did my pattern wrong. That's why I always double check, but I didn't that time. 4, 3, 2. No Q, Q, Q2. I blended the next one, which would have been 4 P Q to the third plus the 1 Q to the fourth. I blended these two. I apologize. You guys probably picked up on it, and then I didn't. So 1, 2, 3, 4. There's five terms in 4. So probability of all correct. 3, 2, 1, none. Okay. All right. So what was the probability of 2 correct? It would have been, so this is 4 correct, 3 correct, 2 correct. 6, so this would have been squared. That's what I had wrong. I'm going to put that in the calculator. I get 0.1536. So this one up here was 0.1%. This one's 15% of getting 2 correct. Okay, so you can see how you use this binomial theorem in the probability world. Okay, so there's my examples, and hopefully you found this helpful. It's a super long video.